Hello everyone, I hope you're all healthy. I'm Louis Marmet, adjunct professor at York University in Toronto. I would like to thank the organizers of the FRB 2021 conference for the opportunity to present this talk. Today I will discuss a simple tool that can be used to improve our knowledge of FRB hosts and the process behind the production of fast radio bursts. The idea is to use a chi-square analysis of the data to see which hypothesis is more likely to fit. I write a total dispersion as a direction-dependent dispersion measure, a constant dispersion measure, so mostly from the halo, a dispersion measure contribution from the cosmology as a function of redshift, and the dispersion measure of the host itself. The equation is rewritten in terms of residuals by subtracting the observed dispersion measure. Adjustable parameters are also added, one for the dispersion measure of the halo, one for the dispersion measure of the host, and a parameter which is based on the one other property of the host or the FRB. The cosmology is adjusted in order to minimize chi-square. The property of the host can be, for example, the absolute luminosity, its mass, or the star forming rate of the galaxy, and also the relationship between the host and FRB. And finally, two cosmologies were looked at, lambda CDM and a simple tired light model. Without any adjustable parameter, the chi-squared value is 1.13. When we add one adjustable parameter, we see that in general, in this analysis, there is a tendency to an overall larger dispersion measure. By adjusting two parameters, we get chi-squared is 0.92, or even better, if the pulse width of the FRB and the star forming rate are considered, then chi-square is reduced to 0.82. Finally, with the tired light model, we get an even further improvement in chi-square by using the mass of the host as an adjustable parameter. So in conclusion, this analysis gives us more information about FRB generation. The dispersion measure correlates with the FRB pulse width and the star formation rate of the host. There's a tendency to fit an overall larger dispersion measure. Maybe it can help improve our knowledge of the Milky Way halo. And cosmology tests could also be performed by varying various parameters or even testing different cosmologies. Since in this analysis several parameters were set to 0, the number of degrees of freedom is actually very low. So we do need many more FRBs with the redshift of an associated host to make these conclusions more significant. Thank you very much.